Hello everyone, let's learn Ohm's law today. So let's first learn what is current. So in a metal we have move of charges. Now we have discussed that the spontaneous motion of charges, if you average over time and if there is no electric field, it will add up to zero. Now if you do have an electric field presented as this, you're going to have a drifting of charges. Now current is defined as the charges moving through a cross-section for a unit amount of time. So which means the amount of charge moving across this cross-section divided by the time it takes give me my current. And we can take a limiting case. What if your delta t goes to 0? Then of course it becomes a differential derivative dq dt give me I. You can also write it as delta q as delta t, delta q over delta t. And the direction of current is defined by the motion of positive charge, by the direction of motion of positive charge. Now what's going to happen if you have negative charge moving? In such a case, if you have negative charge move, we're going to define current to be in the opposite direction of negative charge moving. Now, after all, you need to sum of the charge of positive charge. You have to sum the current by positive charge and sum the current by negative charge. You can call this is positive charge, current by negative. You have to add them together and it will give you the net current. Now in a metal, because the mass of nucleus are much more large than mass of electrons, so electron is much more easy to move. So most of the time in the metal, the current is coming from motion of electrons rather than nucleus. And for ohmic resistors, we have Ohm's law. Ohm's law tells that the current and the potential applied, the potential applied on the resistor and the current going through the resistor, they have a proportional relationship. And if you draw I in the y direction, v in the x direction, then the slope give me 1 over r. Now of course, if you draw your v in the y and I in the x, then the slope gives you r. And then we also have, if you know the resistivity of a metal, then if you have a piece of metal, you know the length, and then you know the cross section. Then its resistance is given by resistivity times length over area. And also we have Ohm's law. You can remain as V equal IR, or I equals V over R, or R is V over I. Now the three equations are all equivalent. So if you want, you can just remember, for example, the first one, and then you can derive the second and the third one. So for our first example, we have a copper wire, and then we know the resistivity of copper is 1.72 times 10 to the negative 8. And then we know the cross-section, we know the length. We want to find out what's the resistance of this wire. So we should use the first equation we learned, R equal rho L over A equals 1.72 10 to the negative 8 50 8.17 10 to the negative 7 omega. Put it into calculators, we find it's 1.05 omega. The next is asked what's the potential difference between 2 points. Now it tells us the current is 1.6 ampere, and we know the resistance. We just calculate this, and then ask us what is V. So which equation are we going to use? Ohm's law. V equal I times R. So we have V equals I times R. Plug in all the numbers. Gives me 1.75 volt. Now let's introduce the concept of electromotive force. Electric motive force is to have the charges move inside the EMF, such as a battery. Now, electromotive force is not a force. It's really a device that to create potential difference for you in a circuit, like batteries or power supplies. It's a energy per unit charge quantity, just like potential. So its unit is also volt, 1 joule per coulomb. And we use a symbol. So in circuit, we usually use a symbol epsilon to represent EMF because it's coming from EMF. Now most of the EMFs has a ideal potential. So the claim is to be, for example, 12 volt or 1.5 volt, and this is when nothing is connecting to it. Now if you connect a circuit element to the EMF, usually the terminal voltage is going to be decreased, and it can be think of as this battery has a, it's a device and it has a resistance as well. We call it the internal resistance. And if you connect a light bulb to the two terminals and we measure it, the potential over the light bulb, we call it the terminal potential, and it equals to the potential over those two, right? So this is terminal potential, we call it VAB. Now it depends on how many current you have going through the circuit. The terminal potential equals the nominal EMF subtract current times internal resistance of this EMF. And then we also, for a circuit, you can have resistor using this zig-zag symbol to represent. You have EMF. Now how to draw EMF? You draw one longer line, then one shorter line. A longer line represents the positive end of the EMF. And this is ideal EMF without any internal resistance. And you have realistic EMF which can have some internal resistance. This is voltmeter, this is ampere meter. Okay, now do an example. So we have EMF which has an internal resistance 2 omega. Is nominal EMF is 12 volt. Then we connect it to a 4 omega resistor. What is terminal potential and what is the current? So we build the equation we know. terminal velocity should be epsilon subtract IR. And then we have Ohm's law, VA prime B prime, which is the potential over this resistor. If you have current I goes in, the potential difference should be I times R. And also that's pointing out, if you have current that goes this way, A prime is going to be higher potential compared to B prime, because potential charge is moving from higher potential to lower potential, right? So charge moving from A to B because it's the direction of current. So position A should have higher potential. Now we then check A and A prime is connected by one wire. So we should have VA equals VA prime. B and B prime is connected by one wire. You can imagine the resistance of ampere meter to be 0. So VB equals VB prime, which also gave us VB equals VA prime B prime. So we can build the equation epsilon subtract IR equals IR. And move this term to the right, we have it equals I R plus R. So we can solve for I now. Plugging all the numbers. We find it's 2 amperes. So we find, okay, now we find I. We find I, we are ready to find out what is VAB. So VAB is 12 subtract 2 times 2 volt equals 8 volt. So the terminal velocity, so right, terminal potential. The terminal potential is 8 volts. Now let's talk about the power, how much power a electric circuit is consuming. Let's see, you have an external circuit element, and I know the potential difference between this point A and B. Now if I have a charge Q move from A to B, what would be change of potential difference? It will be delta UVB equals Q VAB, right? That's the change of potential difference, which is a change of energy. So let's think, what is power? Power is defined as change of potential energy, or work, right? Work is a change of potential energy divided by delta T, and so, and then you have Q VAB divided by delta T here, and what is your Q over delta T? And we learned Q over delta T give me I. So potential times current give you power. And for EMF, if you plug in the equation that VAB actually equal to epsilon subtract IR, you find the power of EMF is given by this equation. So let's do our one last example. Calculate the power by R, power by this external resistor, capital R, and what's the energy consumed by the EMF. So the energy consumed by the EMF, which is total power consumed, should be epsilon times I, and we know epsilon is 12, I is 2, watt, 24 watt. What's energy consumed by interlock resistance I squared times R? I is 2, R is 2, 8 watts. And power consumed by the external resistor, 16 watt. And you can find out the power that's drained. In other words, the power we take out from this epsilon equals the power used by internal resistor and the power used by the outside resistor. You can check the number, check it out. 16 plus 8 give you 24. And this page summarizes what we learned. So for the battery, the total energy consumed is I times epsilon. Epsilon is the EMF. And now for circuit element, the power is I times delta V. And we have Ohm's law, delta V equals IR. So you can write your P in different equations. I times V and V equals I times R. So you can also write it as I squared times R. You can also write I as delta V over R. So this term gives you I times delta V. And if you carry it out, you find that P also equals delta V over R. So this is Ohm's law. Thank you very much for your attention. I will see you next time, and good luck with your exam.